So the next problem says solve the following log equation. So this log equation only has one log. So the easiest way to solve this is to take it from log form to exponential form. So the exponential form, just like we practiced a few problems ago, says 8 is the base raised to the second power equals x plus 4. The base to the opposite side of the equal sign equals the argument. Now 8 squared is 64, and now this becomes a linear equation and very simple to solve. I just subtract 4 from both sides and I get x equals 60. So this is my potential solution. I say potential because I have to check. Now there's an easy check here. I don't have to check the whole thing. All I have to do is when I plug in 60 to the problem, I have to make sure that the argument, that's the thing inside the parentheses, 60 plus 4, is positive. And so because this is positive, that's the only required check that I need to do. Now if I wanted to go further and check to make sure that I didn't make any mistakes, you're welcome to, but you don't have to. This is the only check you must do to make sure that there aren't any extraneous solutions. So on this problem, it's quite a bit harder than the last problem because we have two logs. And because we have two logs, we need to use the product rule, which says if you add two logs together, you can multiply their arguments. So I'm going to take the argument x minus 6 times the argument x plus 1. I like to distribute that, so I get x squared plus 1x minus 6x minus 6, which gives me x squared minus 5x minus 6. Now, the x's are still stuck in the argument, so to get them from log form into another form that's going to have the x's out of the argument, we're going to change it to exponential form, very similar to what we did last time. 2 to the 3 is equal to the x squared minus 5x minus 6 argument. The base is 2 raised to the other side, which is now the new exponent 3, equals the argument. Now 2 cubed is 8. Now that I have the x's out of the argument, I can set it equal to 0 and get 0 equals x squared minus 5x minus 14, and that factors into x minus 7, x plus 2. I set each of those equal to 0. And I'm getting x is equal to positive 7 or negative 2, which are my two potential answers. I say potential because I have to check them. Now when I check, I'm only checking to make sure that the argument's not 0. So I'm going to check 7 first. So when I plug in 7, I have log back to the original 7 minus 6. 7 minus 6 is 1, which is positive, plus log base 2 of 7 plus 1. 7 plus 1 is 8, which is positive. That's all I have to do. This is positive, so I am good. Now I would like to check x is equal to negative 2. So when I do that, I'm going to put log base 2 of negative 2 minus 6. Negative 2 minus 6, that's a negative argument, and that is not allowed. Now I didn't even bother doing the second argument, the second log, because if one of them's undefined, then the whole thing doesn't work. So because the argument is negative, I'm going to cancel out the negative 2 and only keep the 7. Now notice that I put a clean x through it. I want to give you credit for that you know you got negative 2, but then I want you to put a clean x through it so that I can still see through it, so I can give you credit, but know that it's not true. Alright, the last problem we have, solve the following system using matrices. Every single part that you can get correct, every single matrix, I'm going to give you some credit on, so don't just skip this. I think you can get some points here. Okay, so on this first problem, I want to get a 1. I put this already into the augmented matrix. I want to get a 1 in the upper left-hand corner. The easiest way to get a 1 in the upper left-hand corner is just to switch row 1 with row 3, because row 3 has a 1 in it already. So I'm going to go ahead and put row 1 up in the row 3 up in the row 1. Row 3 moves down, and I haven't really done anything with row 2, so that's going to stay the same. So for my progress report, I have got a 1 where I want it. Yay! Next, I am trying to get zeros below it. So that's the next thing I'm trying to do. So the rule to get a 0 is you take the opposite of -2, which is +2. The opposite of -2, which is +2, times the row with a 1 in it, which is row 1, and add it to row 2. At the same time, I would like to do 0 in row 3. This is the only step where you can do 2 at a time. If you want to do it in 2 different steps, you can. But I'm going to do it in one here. So I take the opposite of +2, which is -2, times the row with a 1 in it, and add it to the row that we're trying to manipulate. And we're going to put it back into row 3. So what is the row that stays the same here? Looks like row 1 stays the same. And row 2, I'm going to do some work off to the side here. So let's see. I'll do it in red off to the side. So sometimes, I taught you 2 different ways in the video. You can either do it horizontally, so I'm going to take row 1 times 2, so that's 2, -8, 4, and 22. And then I'm going to add it to row 2, which is -2, 1, 3, 20, and then we add down. So if you like to do it that way, go ahead and do it that way. I'll do the other one in the other direction. We can also do it horizontally. So we have -2 row 1 plus row 3. So that's -2. I'm going to write that 4 times. Row 1 is 1, -4, 2, and 11, and row 3 is 2, 2, -1, -13. -22, -35. So I'm getting 0, 10, -5, -35. Now if you like to do it horizontally, do them both horizontally. If you like to do it vertically, but do them both vertically. Okay, so let's do a little progress report. Do I have a 1 where I want it? Yes. Do I have 2 zeros below it? Yes, yes. So the next thing that I am interested in working on is, let's see, I guess I'll do it in gray, this 7. And that 7 I would like to become a 1. And the rule to get a 1 is multiply by its reciprocal, which is 1 over -7. So I'm going to times the entire row by 1 over -7. So what stays the same? Well, row 1 and row 3 are staying the same. And then I'm just going to take every single item in row 2 and basically divide it by -7. We have to write it multiply by 1/7, 1 over -7, but if you want to just think of it as divide, you're welcome to. 0 divided by 0 is 0. -7 divided by 7 is 1. +7 divided by -7 is -1. 42 divided by -7 is -6. Let's do our progress report. Do I have a 1? Yes. Do I have zeros below it? Yes, yes. Do I have a 1? Yes. So what is the next thing that I am going to be working on? It looks like the next thing I need to work on is the 10. And the 10 needs to become a 0. So the rule to get a 0 is you take the opposite sign of 10, so that's -10, times the row with a 1 in it. The row with the 1 in it, that's that yellow highlighted 1 that I'm talking about, which just happens to be row 2, and add it back into the row. Now, I don't care if you do this horizontally or vertically, whatever makes you happy. I have to pick one right now, so I guess I'll do it vertically. So if I take negative 10 times row 2, over here that's 0, negative 10, positive 10, positive 60, and add it to row 3, which is 0, 10, negative 5, negative 35, and add down. 0, no big surprise, I wasn't trying to change that. Negative 10 plus 10 is 0, no big surprise, that's what I was trying to get happen. And then 5, and then 25. So on my next matrix, I have 1, negative 4, 2, 11, 0, 1, negative 1, negative 6. Those don't change. And then I have 0, 0, 5, and 25 for my last spot, my last row. Now, if I do my progress report, I have a 0, I have a 1 in the upper left, 2 zeros below it. I have a 1 down the diagonal and a 0 below it. So the last thing that I'm working on is to get this 5 to become a 1. In order to get the 5 to become a 1, I multiply. The rule says to multiply by its reciprocal, which is 1/5. Notice that row 1 and row 2 stay the same. And then I'm just going to take row 3 and divide it by 5. 0 divided by 5 is 0. 0 divided by 5 is 0. 5 divided by 5 is 1. 25 divided by 5 is 5. So with my progress report, I have a 1 where I want it and zeros below it. I have a 1 where I want it and 0 below it, and I have a 1. So this is in the correct form, and now I have all of my matrix works done, and now I need to back substitute. So to back substitute, I'm first going to rewrite my new matrix back into equation forms. So I'm going to rewrite this as x minus 4y plus 2z equals 11. Then I have y minus z equals negative 6, and then z equals 5. And then I'm going to rewrite it one more time because I want to solve for the x, the y, and the z. So I am going to rewrite these using transposition. So to get x all by itself, I'm going to move the two terms that are next to it. So the 4y goes to the other side, and because I change it to the other side, it becomes positive. Then I take the negative 2z and change it to the other side, and it becomes negative. And then on the y, I have y equals, the z needs to move. So the z changes from negative to positive. Notice that the 6 was negative and it stayed negative because it didn't change sides. And then z is equal to 5. So in my solution, I already know in the xyz that z is 5. It's already solved. In order to find out what y is, I'm going to take z and back substitute it into the y equation. So that's 5 minus 6, which is negative 1. Okay, to find the x, I'm going to take both 5 and negative 1 and plug it into the x equation. So the x equation says x equals 4 times y, but my y is negative 1, minus 2 times z, but z is 5, plus 11. So that's negative 4 minus 10, which is negative 14, plus 11, which turns out to be negative 3. So this is the solution using matrices with row operations and then back substituting to find the solution. If you are not sure, you could check your work by plugging negative 3, negative 1, 5, which is the solution we got, into each one of these equations. And just checking to make sure that it works. I'll do one with you here. If you take 2 times negative 3, that's the first equation, plus 2 times y, which is negative 1, minus 5, that gets me, let's see, negative 6 minus 2, that's negative 8. Negative 2 minus 5 is, negative 8 minus 5 is 13. So it does work for this one. You can go and check the other two at your leisure. It does work, and so this is the correct solution. That checking is totally optional. You do not have to do that. And this concludes our final exam review. Good luck, guys. Study hard.